Did you know that fixed end moment formula is derived by using force method? We have demonstrated the derivation for a prop cantilever in previous video. In this video, we are going to look into the derivation of this formula for a fixed end beam. For those who don't know, fixed end moment formula hastens our process in determining reaction and internal forces developed in statically indeterminate beam. Let's say we have a fixed end beam subjected to uniformly distributed load W. The degree of indeterminacy is 3. However, we may consider making two reactions redundant, namely By and Mb. Bx may be neglected since it does not affect the development of internal shear force and bending moment, and eventually the beam deflection. As a result, we establish three analysis cases. First case is where the primary structure subjected to uniformly distributed load. The second case is where the cantilever is loaded with unit concentrated load at free end, while in the third case, a couple moment is applied instead. Two compatibility equations are established. One of them tackles the vertical reaction based on deflection, while the other tackles the moment based on beam rotation. These compatibility equations adhere to principle of superposition. In other words, the effect of original loading and redundant forces need to be considered when determining beam deflection at one point. Next, let's find out the beam deflection and rotation for all cases. For redundant force cases, we determine the deformation due to one unit load and couple moment. To do so, we simply refer to readily available formula for a cantilever beam. One thing to note is sign convention for deflection and rotation. The empirical formula is applicable to certain conditions. When the loading is in the opposite direction from that condition, negative sign needs to be introduced to the value of deflection and rotation. We can now deploy our compatibility equations and substitute our findings into them. We have two simultaneous equations to solve for two unknowns, By and Mb. After we determine the redundant reaction forces, we can simply determine the reaction on the other side by mirroring them. This is only applicable if the structure is symmetrical. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.